I got that a little too hot. You don't want to burn the material. The art of blacksmithing has a history that's thousands of years old. For most of that time, the material of choice has been wrought iron. This is iron ore that has been processed and then forged out, folded back on itself, forged out again, often using a silica sand as a flux, and that's where the term wrought comes from. That gives kind of a fibrous material with a grain similar to what wood has, and oftentimes you have to have a thought process similar to what you would use when working with wood. So when you're looking at historic ironwork, the work of Samuel Yellin, work all across Europe, medieval work, the fantastic hinges on the Notre Dame Cathedral, that work is all done in wrought iron. And there's some real advantages to working in wrought iron. Unfortunately, wrought iron isn't particularly easy to come by these days. It's not being made in any kind of large quantities. There are some small museum sites that are manufacturing wrought iron for historic purposes, and people that do small smelts, similar to what we did here several years ago, making little tiny batches of wrought iron, but nothing big enough to really keep a blacksmith shop in business. So you're stuck with salvaged wrought iron, old wagon tires, old rivets, pieces out of bridges, things like that, and frequently it isn't real high quality, and it's hard to come by reliably. As a modern blacksmith, we really don't have access to enough wrought iron to do all of the work we would like to do. So we work with mild steel, either A36 mild steel, which is your typical structural steel, or maybe 1018, which is kind of a lower carbon steel and probably a little bit better than the A36. Well, wrought iron can be worked very hot and needed to be worked hot, otherwise it tends to delaminate or split. Mild steel can't be worked quite as high a temperature because it will burn, and it does have some other issues that way. So when we start looking at doing finer work, more architectural work, it would be nice to have something that is even lower in carbon than the 1018 steel. Recently, I received some 1008 steel. This is not something that's very common. You can't go to your normal steel supplier and buy it, but this is extremely low carbon steel. This came from one of the members of the Historic Blacksmith Conservancy. They're currently working to get a mill run of even lower carbon steel, 1006, so that's 6 points of carbon, or 0.06% of carbon. That's a very low carbon steel. It is about as close to pure iron as we're going to get, but without the fibrous nature of the wrought iron, which means it should be a little bit easier and more forgiving to work with than wrought iron is, although it won't have that grain structure, which may or may not be desirable in your work. And I'll talk more about how to get in on the initial mill run of that 1006 steel, how you get your name on the list, and what's going to be available before the end of the video. But the first thing I want to do is see how this works, and I want to draw this out. This is 12 inches of 1 5/8 round. I want to draw it out into either 1/2 by 1 or 3/8 by 1. I'll probably start at 1/2 by 1, see what I think and how much material I got, and then decide if I'm going to draw it out a little bit further to make it thinner. Before the video is out then, I will turn some of that into a framework that we can later make a grill out of, and I will use the other piece of this, I've got 2 pieces, to make the internal components for the grill. Scrolls, leaves, I'm not even sure yet. I don't have a design in mind. I just want to play with this material and see what it does for me. So let's light the forge, head over to the power hammer. This may be an hour or more to get this drawn out, so I'm not going to show the entire process. We'll show a lot more when we actually get to working with this and creating something out of the bar stock that we create. 12-inch long piece of 1 5/8 round yielded 47 inches of 1/2 by 1. I think I would like a little bit more than that. I don't think that'll make a very big grill. And proportionately, 1/2-inch thick bar would be really heavy for a grill that small. So I think I'm going to go down to 3/8 of an inch by 1 and see what that does. Based on this, I should come out close to 5 feet. Well, what was your guess on how long this would become? Starting with 12 inches, 1 5/8 round bar, I ended up with a piece of 3/8 by 1 inch flat bar that is almost 5 feet long, 58 3/4 inches to be exact. And I could probably draw this out just a little bit to make it exactly 5 feet long, but I don't think I need to, although there are a few thick spots that maybe I didn't have the kiss block position just exactly right. But in any case, I don't think we're going to have any trouble making a grill of about 12 by 18 inches out of this. I'm going to think on this overnight, get my sketchbook out now that I know how much material I have to work with, and come up with some sort of a design for the overall grill based on what this length is. But for you, I'll be right back. Now, my only goal at this point is to make a frame for a grill. Exactly what that grill will look like will be a future video. And there are so many different options that we have for making that frame. It can be oriented so you're looking at the edge when you're looking at the grill. It could be oriented so you're looking at the flat. It could be a rectangular grill. It could be a square grill. It could be a round grill. But I think I'm going to go for an archtop grill. This gives us a chance to try a few different techniques, bending the arch, doing square corners on the bottom, so upset square corners, and a forge weld in the middle. Now, I did take the time to sketch out kind of what I have in mind for this grill. It may change before we actually get to the follow-up video. But this is where I think I'm going with it. So the first thing I want to do is lay this out. I'm not going for a very specific size on this. I want to use all of the material, so I'm going to let the grill adapt a little bit to what the material wants to do. I will make it a fixed width, and that is 12 inches on the inside of the grill. So that's going to be my fixed width. That's my goal. And then the height of the grill will be whatever the height ends up. My calculations say it should be about 19 inches, but we'll see exactly. So for 12 inches on the inside of the frame, I need to calculate to the center line of the frame, which would be 12 3/8 inches. Plus, I then need to calculate for the material that'll be used up creating that square corner, which is another 50% of the width, or 3/16 on either side. So I need 12 3/4 inches, so that's 6 3/8 inches from each end to where my square corners are going to be. Yes, this would be easier to calculate in the metric system, but here in the US, we don't use the metric system, so you have to be comfortable with fractional measurements if that's the system you work with. With all those measurements marked out, I'm actually going to start with the scarfs for the weld, so I can do that while I still have a flat bar. Then I'll go on to bending the corners and finally bend the arch on the top to bring those scarves together for the weld. Okay, I've got our frame bent to shape. You'll notice that it's a little narrower at the bottom than it is up at the top. That's because as I do the forge weld, this is going to draw out again. That's just one reason to upset the material as you do the scarf. Otherwise, you end up with things a little bit too thin. But I think we're ready to forge weld. I've cleaned out my fire, got rid of the clinker, built it back up again, have a nice clean fire to work in, and this should go pretty smoothly. I got that a little too hot. You don't want to burn the material. Well, after much fiddling to get this thing square and even, sides parallel, all of that, I think I have just what I was going after. Now, I was going after 12 inches on the inside, and I'm at 11 7/8. I'm okay with that. And I'm at 19 on the inside for the height. And I think I was going for 18 to 19. I don't remember what I said at the beginning of the video. But in any case, this is what I was after, and this is what one piece of this 1008 steel gave me. I wasn't going for a specific size to fit a specific location. It was just, what could I get out of this piece of steel? This leaves me this other piece of 1008 steel that I can use for all of the center elements. I need a center divider and then some branching S-scrolls on either side. And that's all going to be another video, because I've got to start by drawing this out probably to 1/4 by 3/4 for the infill on this. And hopefully I can get enough. If not, I may have to make it a little bit thinner just so I can do all of this project with these two pieces of steel that I was sent. My thoughts on this low carbon steel: forges way easier, even though I did burn it while I was doing the weld. I don't think it burned as easily, and certainly didn't burn as badly. I was able to pretty much forge all that in, so that's not going to show in the finished piece. And I could continue to forge this down into a lower heat than I might mild steel, and it was still moving, and I wasn't worried about cracking it or anything. So it's really a forgiving material, much easier to forge. You can get it a little bit hotter for the forge weld, which makes the forge weld easy. In fact, that forge weld went together so easily, I wasn't sure it was really sticking at first because it just welded. To use a much overused phrase, it was like working with warm butter. So what's the deal on this? The Historic Blacksmith Conservancy is working on a mill run order of 1006, slightly less carbon than this is, should be every bit as good, if not slightly better than this. And all of that information is available over on their website. I will link to their website down below. So if you're interested in getting in on that initial order, not going to be cheap stuff. You're going to have to pay a premium for it, and you're going to have to pay shipping. Because for most people ordering a significant amount of this, it's going to have to come truck freight. It's going to be expensive material and not something you use probably for making bottle openers and steak flippers, but for doing ornamental work, I think it's going to be a wonderful material. So thanks for sending this out. It was fun to work with. We're going to get back to this grill. We're going to finish it. Probably not for another 4 to 6 weeks, something like that. I got a lot of other things out of the shop I got to do. So I probably won't have time to really concentrate on this, but we will get back to it, I promise. I want to thank each and every one of you for taking your time to watch today's video, with a special shout out to my channel members and my Patreon patrons. Channel members receive early access to the videos, while my Patreon patrons at a certain level not only receive early access, they receive those videos ad-free and as much as is reasonably possible. I try to edit out most of the sponsored content if there's a paid sponsor. So if you're tired of the ads here on YouTube, you don't really like the sponsored content, and you would like to help support the channel financially, Patreon is a great place to do that. But again, thank you everybody for watching. I hope you have time in your day to get out to your shop, make something, have fun, try something new, but stay safe, wear your safety glasses. We'll see you for the next video.